So the last thing we want to talk about in this lesson is how to identify exponential behavior. So we're going to be given a set of data and we're going to determine whether the set of data shown displays exponential behavior, and then we're going to be able to explain why. There's two methods. I want you to put a star next to method 1 because method 1 is the way you're going to use. I'm going to show you method 2, but method 1 makes a lot more sense and it's much more practical because you don't need a graphing calculator. So method 1, we're going to look for a pattern, and the domain values are at regular intervals of 5, okay? What that's saying is x is increasing by the same amount of 5 every single time. So we've got a common factor of 5. That's good. You want to make sure x is always increasing by the same amount. Now we're going to look for a common factor among the range values. Well, for 64 to 32 to 16 to 8 to 4 to 2, what we're trying to see is there something I'm multiplying by every single time to get the same thing? So how to get this multiplication, you can just do 32 divided by 64. You get 1/2. So 64 times 1/2 is 32. Same thing, 16 divided by 32 is 1/2. So if you do 32 times 1/2, you get 16. So on and so forth. Now, this does display exponential behavior, yes, and explain why. It has a common factor multiplied by each term. And once we actually get into writing these, which I think is either, it's in the next lesson or in 2 lessons, I'm not entirely sure. Once we actually get into writing these, you're going to see where this common factor comes in. But just so you can see what it looks like, it's because we always have this a, b to the x. What we're looking for here is what this b term is. This times 1/2 is that b term. Because if you notice, 64 times 1/2 to the first power would give you 32. And 64 times 1/2 to the second power would end up giving you the 16, and so on. But that'll make much more sense once we actually talk about that. So don't be too concerned if this part seems confusing. Just be able to identify the common factor multiplied by each term. And the common factor means it has to be the same. It could not be 1/2, 1/3, 1/4, 1/2. It can't be different things. It's always got to be the same as long as x is the same. The other method to do this is to graph the data. So you'd plot all the points and you'd say, oh look, this looks like an exponential decay function. So this must be true. This is not as accurate, so I want you to just put an X through this. Be able to look at a graph and tell that it's exponential. You can all do that. This is not nearly as exact as doing it the other way. And also it requires you plotting the points and having a graphing calculator, which some of you may not know how to do. But we can all look at something and identify a pattern. This is a much simpler way to do it. That's all there is for this lesson. Let me know if you have any questions.